At the edge of everything, where light itself reaches its final boundary, something is moving. It should be frozen by cosmic expansion, locked in the oldest visible moments of time. Yet, the measurements show motion. Tonight, we investigate the object at the edge of reality that may reveal something pulling from beyond the observable universe.
At the edge of everything, something moves that should be frozen forever. 13.8 billion light-years distant, positioned at the observable threshold of space-time itself, an object exhibits motion that cosmology cannot digest. Proper motion. Transverse velocity, movement perpendicular to our line of sight. At that distance, cosmic expansion should render such motion invisible, erased, impossible. Yet the measurements do not lie. What force commands an object to move at the boundary where movement should cease to exist? The observable universe possesses an edge not of space, but of time. Light from the most distant objects has traveled 13.8 billion years to reach our instruments. Those objects occupy a boundary where look-back time approaches the age of the cosmos itself. At such extremes, the expansion of space stretches wavelengths into oblivion. Objects recede faster than light. Their positions become coordinates frozen in deep time. Transverse motion, sideways drift, should vanish beneath the roar of cosmic expansion. Deep survey telescopes scanning the constellation Eridanus detected the object during multi-epoch observations. Astrophotography separated by months, then years. The quasar appeared in identical spectral position. Same redshift, same distance estimate, 13.8 billion light-years. But its coordinates had shifted, minutely, measurably. Motion perpendicular to radial recession. The team recalibrated instruments, reprocessed data. The motion persisted, an object at the cosmic edge, drifting sideways through space-time as if unbound by the universe's expansion. Hubble's law governs recession velocity. Distance multiplied by the Hubble constant yields the speed at which space itself expands between observer and object. At 13.8 billion light-years, that velocity exceeds the speed of light, not through motion, but through the metric expansion of space-time. Proper motion, angular drift across the sky, requires transverse velocity components detectable above the noise of expansion. At such distances, those components should be quantum scale, unmeasurable. The equations forbid what the instruments record. Cosmic expansion is not velocity through space. It is the creation of space itself. Between distant galaxies, new space-time manifests continuously. At local scales, solar systems, galaxies, even galaxy clusters, gravity overwhelms expansion. But beyond hundreds of millions of light-years, expansion dominates absolutely. Objects recede not because they move, but because the distance between them grows. At the cosmic horizon, expansion operates with such force that transverse motion becomes cosmologically irrelevant, invisible, erased by geometry. The object's proper motion measures 600 kilometers per second, perpendicular to radial recession. At closer distances, unremarkable. Galaxies drift. Gravitational interactions induce bulk flows. But at 13.8 billion light-years, 600 kilometers per second transverse velocity generates angular motion detectable across cosmic epochs. The probability of measurement error, less than 1 in 10 million. The object moves, and its motion vector does not point toward any known gravitational source within the observable universe. Spectroscopic analysis confirms redshift Z equals 9.7. Light from the quasar has been stretched to 9.7 times its emitted wavelength. This places the object in the epoch of Ryanization, less than 500 million years after the Big Bang. Multiple independent observations across observatories verify the measurement. Distance is not uncertain. The object occupies the boundary of observable spacetime, and from that boundary, it moves as if compelled by forces our equations do not contain. Radial motion, toward or away from the observer, remains detectable at any distance via Doppler shift. But transverse motion, requires angular displacement, measurable against the cosmic distance scale. At 13.8 billion light-years, even relativistic sideways velocities produce angular shifts measured in micro-arcseconds per century, detectable only through decades of precision astrometry. The object's motion exceeds predicted bounds by 3 orders of magnitude. Something accelerates it, perpendicular to cosmic expansion with sustained directional force. Gravity operates across any distance. Mass curves, spacetime. Curvature dictates geodesics. Objects follow geodesics as tides pull moons and planets into orbit, but at cosmological scales, gravity's influence weakens beneath expansion's geometric onslaught to induce 600 kilometers per second transverse motion at 13.8 billion light-years requires gravitational potential from mass concentrations exceeding 10 to the 18th solar masses. Structures larger than superclusters, entities that should not exist within standard cosmological models.
The strange part is not that the object exists. The strange part is that it moves sideways across the sky, from a distance where that motion should vanish beneath cosmic expansion. If the data is correct, the universe we observe is not isolated. Something beyond the horizon may be shaping what happens within it.
In 2008, astronomers identified dark flow, galaxy clusters moving with coherent velocity toward a region in the constellation Centaurus, hundreds of clusters drifting at 600 kilometers per second in the same direction. Analysis suggested gravitational influence from beyond the cosmic horizon, mass concentrations outside observable spacetime exerting measurable pull. Dark flow remains contested, debated, unresolved. But the object at the edge exhibits motion consistent with such influence, except its vector points elsewhere, toward a different beyond. Within 250 million light-years lies the Great Attractor, a gravitational anomaly drawing the local group Virgo supercluster and Hydra Centaurus regions toward a common center. Its mass, tens of thousands of galaxy equivalents. Its influence, profound across local cosmological scales. But the Great Attractor cannot reach across 13 billion light-years. Gravity weakens with distance. Expansion dominates. No structure within the observable universe possesses sufficient mass and proximity to command the object at the edge. The observable universe is finite, not because space ends, but because light has traveled only so far since the Big Bang. Beyond the cosmic horizon lies more universe, unobservable, causally disconnected. Light from those regions has not had time to reach us. They exist outside our past light cone. Standard cosmology assumes homogeneity. The universe beyond the horizon resembles the universe within. But if mass distributions beyond are inhomogeneous, concentrated, asymmetric, their gravity propagates at light speed, arriving before their light. String theory proposes our universe as a three-dimensional brane embedded in higher dimensional bulk. Other branes, other universes, float through that bulk, separated by dimensions we cannot perceive. Gravity, unlike electromagnetism or nuclear forces, may propagate through the bulk. If another brane drifts sufficiently close, its gravitational influence could bleed through dimensional boundaries. The object at the edge might be responding not to mass within our universe, but to mass in a parallel cosmos separated by fractions of a millimeter in dimensions we cannot access. The cosmic microwave background, radiation from 380,000 years after the Big Bang, exhibits anomalies, cold spots, asymmetries in temperature fluctuations. Some cosmologists interpret these as bruises, scars from collisions between our universe and neighboring branes during inflationary epochs. If our universe has collided before, it may collide again. The object's motion could trace gravitational echoes of brane interactions occurring across dimensions and epochs beyond direct observation. Evidence written in motion, not light. If the object responds to gravitational influence from beyond the observable universe, then mass beyond the horizon is not homogeneously distributed. Somewhere in the unobservable vastness lies a concentration vast enough to warp spacetime across causally disconnected regions. A structure so immense it exerts pull across boundaries light cannot cross, not a supercluster, not a galactic filament, something orders of magnitude larger, an entity that redefines the scale at which cosmic architecture operates, and we perceive only its shadow. Gravity is geometry. Mass tells spacetime how to curve. Curvature tells mass how to move. The object at the edge follows a geodesic dictated by spacetime curvature we cannot map. If that curvature originates beyond the observable universe, then our cosmological models are incomplete. We measure the cosmos as if it were a closed system, but closed systems do not exhibit net acceleration toward external influences. The object's motion is testimony. Something beyond the horizon commands space-time within it. The object moves. That motion is measurable, reproducible, undeniable. Its velocity exceeds prediction by magnitudes that cannot be dismissed as error. The equations that govern cosmic expansion, gravitational influence, and observable limits are not wrong. They are incomplete. The universe we observe is not isolated. Forces beyond the horizon reach inward. Mass we cannot see dictates motion we can measure. The edge we call the boundary of everything is only the boundary of perception. Beyond it lies more, and that more is not indifferent. What force commands an object to move at the boundary where movement should cease? Gravity from beyond the observable universe. Mass concentrations so vast they curve space-time across causally disconnected regions. The object at the edge does not move alone. It is pulled, drawn by architecture we can never chart, toward destinations we can never observe. The cosmos is larger than the light that reaches us, and what lies beyond watches, pulls, commands. If this truth unsettles the foundations of your understanding, return. The observatory will be here. Subscribe.
The edge of the universe is not an ending. It is only the limit of what light has been allowed to show us. Beyond it, something may still pull, bend, and command. If you want to follow the evidence past the last visible star, like this video, subscribe to the observatory, and keep watching. The horizon has not finished speaking.